What is .NET Framework? Here we're going to discuss the .NET Framework. Let's first off see what is meant by framework. The dictionary states that the meaning of framework is a structure or skeleton. Now we'll see what is meant by .NET Framework. Is this a language? Well, no. It's an overall structure which holds all the components to provide better implementation. .NET Framework is an environment for building, deploying, and running web services and other applications. It was developed by Microsoft with the codename Next Generation Windows Services, or NGWS. Let's see what all the languages .NET can support. We can write the application logic using VB, C#, J#, and C++, etc. .NET can support more than 30 languages. So let's talk about the basic features of the .NET Framework. The code written in ASP.NET is compiled and not interpreted. This reduces execution time. Platform independence. A model which is developed using .NET Framework can run in an operating system, an OS. It supports the new technology of web services, which is used for accessing application logic and transfers the data across the Internet. Next, let's discuss the basic advantages of the .NET Framework. Well, first off, faster web applications. There are two main factors of ASP.NET which improve the performance of the application. First off is the compiled code. In ASP, the code is interpreted into machine language, whereas in ASP.NET, the code is compiled into machine language. Caching. This is fast storage of information that will be reused in a memory location for faster access in the future. Memory management, garbage collection. Garbage collection, or GC mechanism, is used to remove the unused instances during runtime. Code security. .NET has its own security mechanism with two general features: code access security, known as CAS, and validation and verification. Code access security is based on evidence that is associated with a specific assembly. Now, I hope you've got a better idea about the .NET Framework and its features. In the upcoming lessons, we're going to talk about the components of the .NET Framework and how they work. Various components of .NET Framework. Previously, we discussed about .NET Framework and its features. First off, we'll discuss the architecture of .NET Framework. This is the architecture of .NET Framework. .NET Framework contains various components, such as language layer, common language specification, Windows and web form, ADO.NET and XML, base class library, known as BCL, and common language runtime, also known as CLR. In this lesson, we're going to analyze MSIL.NET assemblies. Now let's start with MSIL, which is Microsoft Intermediate Language. When you compile a program developed in a language that targets the CLR, instead of compiling the source code into machine code, the compiler translates it to Microsoft Intermediate Language, MSIL, or IL, which is Intermediate Language. In addition to translating the code into MSIL, the compiler also produces metadata about the program during the process of compilation. Metadata contains the description of the program, such as classes, interfaces, and some resources. Assemblies. Assembly is a logical grouping of one or more managed codes or resource files. In this figure, we are passing the file names of some managed modules and resources, or data files, to a common tool. This tool produces a single PE, a programmable executable file, that represents the logical grouping of files. This PE file contains a block of data called the manifest, which is simply another set of metadata tables. Now, these tables describe the assembly. Types of assemblies. There are two types of assemblies available in .NET. One is private assemblies, And another is shared assemblies. Private assemblies are created when we build the component files like Dynamic Link Library, otherwise known as DLLs, that can be applied to one application. And shared assemblies are created when we want to share the component files across multiple applications. Common Type System, or CTS, and Common Language Specification, known as CLS. CTS defines the basic data type that IL understands. The use of CTS is to enable deep language integration by allowing code that's written in one language to be inherited by another language. We can say that CTS is responsible for language reusability. CTS allows two different languages to communicate with each other by passing or receiving parameters to and from each other. The CTS tells you how to represent characters and numbers in a program. For example, in VB, the date type to represent numerical values is an integer. Similarly, in C#, we use int. Both are represented in IL code as system.int32. Function of CTS. CTS establishes a framework that helps us enable cross-language integration, type safety, and high-performance code execution. It provides an object-oriented model that supports the complete implementation of many programming languages. Next up, Common Language Specification, or CLS. This is a subset of the CTS, or Common Type System. CLS gives certain rules to the framework. The Common Language Specification, or CLS, specifies the rules, properties, and behaviors of a .NET-compliant programming language. The CLS represents the guidelines defined by the .NET framework. The above-mentioned components of .NET Framework are responsible for converting source code into intermediate code, which can be understood by the CLR. Now, in our next lesson, we're going to discuss CLR. Common Language Runtime, or CLR, JIT Compiler, and GC. CLR is Runtime Execution Environment for .NET. It provides runtime as well as compiles time services, for example, memory management and debugging. CLR works with the CLS, the Common Language Specification, and CTS, the Common Type Systems, to ensure language interoperability. How does it work? Well, let's see how the source code is converted into native code. Before the code can be executed, the .NET Framework needs to convert the MSIL into native code. We've already discussed how the source code is converted into MSIL. Now, the just-in-time compiler translates the code from MSIL into managed native code. During the process of compilation, the JIT compiler compiles only the code that is required during execution, instead of compiling the complete IL code. This process saves the time and memory required to convert the complete IL code into native code. Garbage collection, or GC. We can call this GC an automated memory manager. In .NET, garbage collection is removing the unused objects and resources from the memory. CLR provides the garbage collection feature for managing a lifetime of an object. This GC mechanism helps us avoid manual deallocation processes that can be done by programmers. For example, when we declare a variable, it gets memory in stack, and when we create an object, it gets space in heap, and the reference count is incremented by 1. When the scope of the variable is come out of the program control, object reference count for that object is decreased by 1. When the reference count for that particular object becomes 0, then GC automatically calls destructor to destroy the memory. Now, I hope you've got a clear idea about .NET Framework and its components. In the next lesson, we're going to discuss how to use Visual Studio.NET to develop an application.